Hey guys, before we get started, I want to make a couple of comments about this unit. You know, a lot of us that watch, people who watch my channel watch the same kind of things I do, and they're, about old, tube radios, tube televisions, and, you're accustomed to seeing instances of hundreds of volts, if not thousands of volts, particularly on televisions. But, we can become complacent in terms of thinking that that is usually within the cabinet or within the case. In this case, or this unit, there is actually a wire that hangs outside of the cabinet of this, that if you were to put power to this unit, it'll generate 1,000 volts out at the end of a wire that's just hanging out there. You might not suspect something like that was possible, so I want to give you a heads up on that. So I would encourage you to not try to do anything I'm doing here. If you have one of these, be aware. You may want to take this to a serviceman. If you're not one yourself who's familiar with this kind of equipment and this kind of voltages, and make this safe for your purposes, or not use it at all if you like. But I would encourage you, just take a look at my video. Don't attempt to do anything I'm doing here. Just enjoy looking at some history, and thanks. Okay, well, the light is staying on, so that's looking bad for the photo tube. I'm going to go recheck my wiring and recheck the instructions. Okay, well, I went through a lot of work to turn off all the lights in here and put this box over this and everything, and it's not operating. I've also doubled up the jumpers here to make sure I had good continuity between these connections. And it's still not functioning like it's supposed to. When it's covered up, that light should go out. And it's still lit, as you can see. So what I'm going to do is shut this thing down and go through and do some checking to make sure I get my wires right, and then backtrack to the troubleshooting again. I don't know, it could be maybe some capacitors have changed since we've been operating it and needs to now be readjusted again. I may go back through the beginning of this from the start, but I won't bore you with that until I find something. Meanwhile, I'm going to shut it down and do some research. Things are looking pretty bad for the photomultiplier tube, which I'm pretty sure is hard to find. So, but yeah, I'm not going to give up. There's going to be a part 3. So until then, see you later. Thanks. Bye. Yeah, so I had one of those moments where, you run into a brick wall and you think, oh, something went wrong. You look at what could be wrong in the troubleshooting. Maybe it's the photomultiplier tube is dead. Where are we going to find another one of those and everything? We're not out of the woods yet, but I decided to go take a break, sit down with the manual, go through in the manual again, just kind of walk away from it for a minute. I took the memory card out of the camera and plugged it into the computer to go ahead and download it. And just while I was sitting there thinking, I went ahead and had a couple of the files running just to make sure they transferred okay, and also see if there's anything I saw while I was doing that. And there was a moment where I was saying, now here is where we hook up the leads for all of this. And as I was looking at this, my jaw snapped open. I never grounded this. And I was so excited. I jumped up and I thought, I got to go out there and check it. That may be what it is. And I ran out into the garage, and then the garage door came open, and my wife said, "Honey, would you get all this stuff out of the car for me?" like in Galaxy Quest, when the kid is helping Tim Allen on the communicator, and he needs that last bit of information, but the kid's mom makes him take the trash out. So I dutifully did all of that, and then I ran back in so I can go ahead and do this. So I haven't done anything. I need to get the power back up, and I've got a cable here that I can use to hook up the ground to the ground braid. I had one of these green ones ready to go for that purpose, but ended up using it to give me additional throughput, and that was why it was there, and I didn't remember. Okay, so said all that to say, we are on the last test here. I'm going to disconnect this. And let me bring the voltage back up, get this thing back to going again. Let's see, that'll be DC. Down, this comes up. Vibrator's running. Camera's on. Bring the voltage on up. I need to go ahead and ground it though. Light's on. Not sure the light should be on, but anyway, let's see. I need to put the ground on it. So here's the ground braid, and I need to ground this. Can I ground it to this? Let's see if that works. Okay. You see okay? Yep. All right. Bring the voltage on up. I think that light went out, didn't it? We'll see. I wasn't watching it. Okay, we're at 6 volts. Let it warm up a minute. And where we were with the test was connect this up. Light is on. And now when I cover this up, that light should go out. Let's see if I've got enough dark material here. Let's see. Woohoo! Okay, so off means the high beams are on. Okay, this is showing you the state. This is the current going through the relay coil. So this shows that off means your high beams are on. And now a car comes around the corner with bright lights on, and it dims them to low beams. And then the car passes, and your lights go back to high beams. A car comes by, and let's see, that turns you to low beams, and then he keeps his low beams, his high beams on, and you want to flash at him. So I think you just do, was it this to ground, right? And that should turn them off. And that means, that doesn't turn on, put your high beams on. So, hey man, dim your headlights. He goes by. And then when he goes by, the eye goes into darkness again, and your high beams come back on. It works! Didn't have the darn ground hooked up. Alright. I'm so excited. I don't know what to do next. I think what I might do is just try to rig up a little something here. Maybe bring the relay in, make sure the relay works. But big success. Big success right there. High beams are on. Low beams. High beams. Low beams. Cool. Okay, so here's the relay that goes with this. And hope this thing works. Alright, so let's look at the schematic of this guy here. So here he is. And so normally what you would do is you'd have the hot lead coming from the headlight switch, 6 volts from the car electrical system coming into here, and then it goes both to the amplifier unit, and then it also connects to the battery terminal on the relay, and it is operated by this relay here to go in between sending the voltage to the upper beams or the lower beams, which are of course grounded at the bulb itself. Alright, currently what we have is we have the 6 volts going in directly here. Here's the signal that comes from the amplifier tube that comes down to here. It comes off of Actually, no, it comes off of here first. This is the switch, the sensitive relay. It lets it go one way or the other. And then, so then it comes in, if you got the foot switch in the automatic position, then that feeds the coil of the relay and flips it on at terminal post C. Now the thing I notice is that C is not electrically connected to the 6-volt. So they don't actually have to be together. I can provide 6 volts into the battery terminal separate from the amplifier unit and go directly to the high beams and low beams. I may try that in a minute. But let's just see if the relay works and then if the contact works. So let's just double check that. So I have the relay here. This is indicated C, so this is where it comes from the amplifier unit, from the sensitive relay. And then here we have upper beams and lower beams terminals, and then this one says battery. And then I guess the ground is just right here. Okay, I've got a little 6-volt battery. Let's see if this thing works. I've got a little dry cell here. It's not putting out 6 volts anymore. It needs to be charged. Okay, you see that okay? Okay, so to operate that, what we want to do is put negative on the ground. Put that here. That. And the positive needs to go to C. So here's C. So let's see if this thing works. I hear it clicking. Great. Okay, so what we need to do is see if we're getting continuity through the contacts. Let's rig that up. Okay, so let's see. Okay. Set this down. And then we want to go between ground, right? No, we want to go between the battery, so let's see, it should be in the upper beam position, right? And it is. Sorry, so this is the upper beam. So when this is at rest, the high beams are on, and that's making contact through here. I should have different types of clips on here. Okay, so now I need that connected to there. That connected to there. Okay. So now let's throw the contact to the battery. And I do that by going to C from the battery. All right. The low beam doesn't seem to act like it's got enough to it. Let's go here. That's working. Yeah, those points need to be cleaned. That's what happens. You leave contacts open and you get oxidation on the surfaces. If they've stayed together, you don't get the oxidation, so when you reactivate the switch after a long time, it still works. But in this case, it's been open and it'll need to be cleaned to get it to work again. Hopefully just cycling will do it if I put some current through there. So what I'm going to do is hook it up to where it's got a little bit of current going through here other than just a really low current from here, and see if we can clean that up just electrically. I'm not going to put anything massive through it, but it is designed to take a light bulb, so it should be able to take quite a bit of amps. Let me get that rigged up and we'll see if we can operate this and clean it up. Okay, so I took this battery out and charged it up. I said it's a dry cell, it's a lead acid cell. And it didn't really have a lot of amps to like drive a light bulb, but it's the only 6-volt battery I have, and it should be fine for what we're doing here. What I want to do is put enough amperage through here, but within the limits of what it's supposed to be able to handle, which would be 2 bulbs instead of 1, but this should be okay. Just to have those contacts go through the motion of making contact with some power going through it to help them clean themselves. I mentioned a while ago that if you leave them in the open position, which the low beam is in right now, is open, then over time the points can oxidize. Whereas if they're together, the surfaces where they're contacting together may form oxidation around it, but not over the surface. So those points tend to stay okay, but the ones that are open tend to oxidize. And that's why a lot in the antique radio community, when you unplug the radio, you really ought to go over and turn the switch on so that the contacts go ahead and close, because that helps preserve the points in a closed position. Then when you go to turn on one of your old radios, what you do is switch it off first, which makes them come apart, then plug it into the wall, then turn it on. Anyway, that's one of the points about old points not being used. So let's just see, put this through its paces with some current going through it. Okay, I've got this wired up again here. I don't know if you can see all this. So I've got white lead here going to the battery terminal. I've got a ground lead here going from the negative to the ground on the unit, which is in here. Then I've got 2 wires that go over to the light bulb. Okay, and that's one of them goes to ground, the yellow one, and then the other one is white. And I have that currently wired to the low beam position, which is in the open position now. So now I've got a jumper that'll go from the battery, which is from here to here to here, and maybe I'll hook it up direct. Okay, and we'll make the relay trip and we'll see if we're starting to get any current going through. Yeah, can you see the bulb starting to glow? This doesn't have a lot of amperage delivery on it, so I expect it not to go really bright on us. It takes a while. See it glowing? Okay, so we're making contact through. And what I can do also is I can switch it over to the upper beam position here. It should come on. And that should go off. Goes off because I've switched to the other terminal. Comes back on. So that's the operation of the unit going high beam, low beam. And it's working. There it comes. There it goes. There it comes. There it goes. We do this a couple of times. I'm going to put the contact sensor on it, the continuity tester, and see if it gets through okay. Okay, we're going to see now how it works on the continuity. So, put some proper leads on this guy. Okay. Set it down, let's see. Okay, so we want to go from here, battery terminal. Okay, it's in the off position, so it should be over here on high beam, and it is. And not on this one. Why is it doing that? Because it's connected here. Okay. Okay, so now when I throw the switch, it's working. Remember a while ago that was sounding really iffy and cutting in and out? It's very solid now. Relay works. Excellent. Okay, so here we go. We got the whole system set up now. We got the relay in, we got the auxiliary pedal in. So basically we've got this in now, we've got the relay in, we've got a wiring set up here I'm going to show you real quickly. And then this is not in because I want to keep this battery input separate from the power input here, and I'll explain that now. But that's just a simple two-position switch, and we can look, you know, that's not a big issue. But here's where it comes in from the amplifier and tells the coil to energize. And then what I've got is I've got a small 6-volt battery set up here to go in to operate this switch. I have this lead acid cell battery here. It's not dry cell. I went out and got this thing charged up. I just charged it for a little while, just enough to be able to operate these lights that you see here. So this was the light that we've used for other things, but now what I've done is, if you look in some of the videos of this system working, people put it in the cars, and when the bright lights come on and the low beams switch on, it must be the camera adjusting the exposure to where you really don't see much difference. You see the lights just kind of pulse, but you can't really tell that it's gone to high beam or low beam. And that makes it a little more difficult to demonstrate how the thing works. So what I've done is instead is rigged it up this way where we'll see the high beams and the low beams operating separately. Okay, so what we're going to do is hook this up to this little battery here. And this is not tied into the rest of the system. I've got the positive side comes through just through the battery terminal, and then goes out these two terminals here, depending on whether you're going to low beam or high beam. Okay, so I think I've got this set up. Yep, okay, I'm going to put up the power. So when you get in the car, start the car up, and then you turn on the headlights, that's what puts power to the system. So this is the voltage. Voltage comes up, you hear the vibrator running, and you'll see that the high beams are on. That's because the tubes are not conducting yet. Now the tubes begin to conduct, you get enough current going into the coil, it kicks on and kicked it into low. Okay, we're just getting the voltage up here a little bit. Okay, so now you go out and you start driving, and you get out of an area where you have bright lights around. Okay, so you go into darkness. So let's just see. So the relay switched and it goes into high beam. So now your brights are on. And you go around the corner and here comes another car and the headlights come in and they switch automatically to low. Car goes by, it goes back to high. Another car comes around, you've gone to low, and his high beams are still on because I guess he's being annoying. So you reach your foot up here to the other pedal that is installed, the auxiliary switch. It goes high beam, low beam, high beam, low beam. Hey man, dim your lights, right? And then he goes by, back into darkness, and your high beams come back on. That's pretty cool. All of this to make that happen, and that's really amazing. Okay, so the next thing that's going to happen with this is, let me just turn this down and off. So the next thing that's going to happen with this is, the owner said, if we get this thing all to work, he intends to install this in his car. Now, he has a 1953 Deluxe 210, Chevy 210, that is just, I've seen pictures of it, it looks great. And he wants to put this in the dash because it works. Now, this is in really amazing condition, as you can see, and it's all original. And you know, you might be thinking, oh man, you can put that in the car. Well, you know, hey, it's his car, it's his unit. He doesn't want to just put it on the shelf to show his friends when they come over. He wants to put this in his car, which is a classic, and have this thing work. These paper capacitors that are in here are, well, this amplifier is 70 years old this month. So the capacitors are at least 70 years old in a few more months, right? These things are going to be leaky, and this is the first time they've been used. They probably are going to start becoming a lot more leaky soon. I mean, this one here had 1,000 volts on it just as I was operating this, okay? So if they're not leaking now, they're going to leak more. And there's some that go between the windings on the transformer. So for example, this one, this one here can start to drain down. And the point is it'll end up drawing too much current, and that could damage something. It could even damage the transformer. And so you really can't do that. So his point is that he wants to use this, and he agrees that we should recap this thing so he can drive it. I said, "Are you sure?" And he said, "Yeah, I'll tell you what, just put the caps into a bag and send them to me. If somebody ever wants to put it back, they can do it." But anyway, so that's what we're going to be doing next on this, is recapping this thing, and then we'll just make sure it all works. So if you don't think you can stand watching that happen on this, then you might want to avert your eyes now. Otherwise, here we go. Okay, that's finished. So mica cap is on there. Cleaned up that pin. It actually just had a bunch of wax on it from that capacitor. They'd gotten right in there, the connection, and just kind of melted on those pin contacts. I cleaned them up a little bit. I got that connected. Capacitor 1 is done. Capacitor 2 is done. And we moved the wire over, as we mentioned. We replaced those 2 resistors that were out of spec. It's not actually touching that tab you sent down there. It's actually a long ways from it. And then over here we've got the big cap is changed. That goes straight to ground anyway. That's not a problem. And it goes down here. I had to put an extension on it. The electrolytic is there on top of the relay, and then the other one down there is down at the bottom. So that's 1, 2, 3, 4, 5 caps. All the recapping is done. The band isn't actually touching. Don't know what to do with the tag, but anyway, recap is finished. So now we'll bring this up very slowly and make sure we don't have any shorts. I'll check the wiring again, but make sure we don't have any shorts. And oh, I wanted to put some adhesive on here. I'll do that. But I think it's ready to go. I think there's not much. It'll move around a little bit, so I'll put a little dab of adhesive on there to hold it down, and it'll be fine. Okay, I'll do that and bring it back later. Okay, so I took a couple of additional tries, but I've got that in there just fine. It's not going to be joggling around in the car, so that's going to keep it, I'll feel better about that. Okay, so what to do now is plug this all back together again and make sure it all works. I've changed the capacitors, I've changed some resistors. I think what I should do is take my time, and I'm going to repeat all the power-up steps that I did in the troubleshooting procedure earlier, and that way I can also make an adjustment here if necessary and get this all tuned in as I go. I'm not going to have you sit through all that, but I'm probably going to video it anyway, just in case something goes on that's of interest. I'll bring you back and we can talk about it. Otherwise, hopefully, if all goes well, you're going to either see a problem that may have occurred, or a problem or challenge I had, or there may be something that I sped up. But other than that, hopefully the next thing you see is this thing will all be set up again and ready for a final checkout. So we'll just see. I may show adjusting the voltages and so forth as we go through different stages, but I won't make you have to sit through all that again. So anyway, let's get going. Okay, it's been running for a while. We're still at 6 volts on the input. All right, now I'm going to be measuring DC here, and I want that to say at least 0.85. We're at 966, so we're definitely okay there. Now there is a adjustment. There's an adjustment for that voltage, and there's an adjustment for the voltage out of the ballast resistor. I'm going to make that adjustment now. I didn't see that before because of where it was located. So inside the case, if you remember, I found this tag, and I'll put it up on the screen so you can read it. But it's basically saying that I want to be set up like I am right now. That B is disconnected. It does have the network plugged in from the photo tube unit, but it's an open circuit, so I don't think it matters since B is disconnected. Okay, and so what it says is that I want to measure 3.9 volts over at the primary and 900 volts at where I'm set up there. So why don't we try to see how that looks. Okay, so to do that I will need, and it also says this should be at 6 volts. Let me get that set up. We did pass this test, but I'm going to try to fine tune it some. Okay, so between ground, which I can get right here, okay, and point A, which is at the output of the ballast resistor, ballast tube, which is the side with the resistor on it, right? Yeah, the side with the resistor on it. So that is here. That'll be DC. Okay, it says that should be 3.9. So I think what I want to do is adjust that resistor to get that to be 3.9. That should be at 6. Okay, that's close enough. Okay, now to get that adjusted, you want that to say 3.9 because that's what it said at the factory, with this set at 6. Okay, this high voltage is covered, that high voltage is covered. Hey guys, yeah, so the adjustment of the voltages was kind of an iterative process. You adjusted one, it affected the other, and went back and forth on this, and so finally at the end I went and did it again after I had the eye tube hooked up to make sure I had the whole circuit constructed just as it was in the diagram, and here I am just checking it right after I got done with it all. Yeah, we're good. 3.8 versus 3.9 and right at 900 volts. So that's all adjusted properly. Okay, we're ready to go for the full system test. We've got everything that's in the system with the exception of the switch that either turns the thing on or off, which is the normal dimmer switch button in the car, which is this one. Okay, so we've got the battery hooked up to operate the lights as it operates through this relay. Here's the relay here. Okay, it's going to show that when the coil is not energized, the battery will naturally communicate to the upper beams, the high beams, which is what we show right here. When the coil energizes, it'll pull that down, and then our low beams will come on instead. And here's the low beam light indicator right here. This is showing the condition of the status of the relay. Alright, so here's the signal that comes in from the Autronic-Eye unit that goes to the coil. So that is this lead here that comes from in here, from the sensitive relay, they call it. Okay, so we're all set to go. And what it'll do is, I think it comes on in high until it turns on. So if you start your car, I think it's in high until the thing unit warms up, tubes begin to conduct, and then your lights go to low. So here we go. Vibrator's running. 2 amps. Relay just flipped. So that means you're sitting there in your driveway underneath the porch light, and you start up your car, and the amplifier unit starts to warm up, and then the tubes conduct. And when the tubes conduct, the sensitive relay is flipped, and your lights go to low because there's lights by your porch light. Okay, so you drive away from your house, maybe drive away from city lights, and then you get out into the country where it's dark and there's no headlights coming at you. And so what it does is it puts the eye tube into darkness. And let's see what happens here. Your bright lights come on. A car comes up around the corner, headlights shine in the window, and your low lights come on. Go back into darkness, and your bright lights come back on. Another car comes around the corner, He leaves his brights on. You say, hey man, dim your lights. He goes by, back in the darkness. Okay, the system works, and I'm going to leave it cooking for a little bit to make sure that the capacitors are all okay, but for the amount of testing I've done, I'm sure it's okay. It's functioning just like it's supposed to. The current looks good. The performance is like it's supposed to be. We verified a while ago. I noticed that you couldn't see what these meters up here were reading, but I think I called it out. This one right over here was right at 9 volts, 900 volts DC, and this one was about, I think it was 3.85 or something like that, very close to 3.9. So I think we're right in where we need to be on those things. So yeah, there it is. The system works. And I'm going to put the cover back on, and we'll be done with this thing. So I know some of you guys are looking at this picture and thinking, oh no. No, I'm not going to do what you're thinking I'm going to do. So those of you that might not be aware, though, I just want to make a quick explanation. When I went in and took these capacitors, these are the capacitors that were in the Autronic-Eye, okay? And I took these things out. You know, some of you might have been thinking, what are you doing that for? I mean, it looks all really good and so forth. And I would encourage you, if you're interested, there are any number of excellent videos on how these paper and foil capacitors over the decades start turning into resistors. Okay, and you can have a piece of equipment like this that you can check that. I don't hardly ever use this anymore because it's kind of like this is like 8-year-old milk. I mean, you don't even try it. I mean, just replace it. Okay. But we can take a quick look at one of these just for an example. But one of the reasons it's kind of strange I'm getting this out is I'm also building. I've already built this. This is a capacitor tester, a capacitor leakage tester that was put out by the Antique Wireless Association. I saw this off of X-Ray Tony B's website, and I'm building my own version of this. But I haven't got it completed yet. But I've got the board done, and I'm building the box and so forth that it goes in, and I don't have it finished yet. I'm working on other things, but I pulled this out just kind of as a way to demonstrate. I'll test one of these, but you know, you can go look at any, as I say, any number of videos that describe, you know, how this works and what it does, and much better explanation I'm going to give you. I'm just going to do it really fast. Okay, so what I'm going to do is I'm going to turn this thing on and let it get warmed up. It's got a rectifier tube in it, and it's got a magic eye tube. You need to let that warm up, and then I need to adjust the lighting in here so that we can maybe see the eye when it comes up. So let me get that set up, and I'll be right back. You can see it starting to glow. Okay, good. You can see the eye pretty good now. I got it darkened up in here where you can see it. When you're using one of these devices, you know, in person in front of them, it's very easy to see the eye because you don't normally have the bright lights we have when we're doing videos on these things. So anyway, these are the capacitors, as I talked about a little while ago, and some of these are, you know, 50 volts and so forth. It's not going to make the point I want to make here. This particular one, this is the big one. This is the one that's 1600 volts on it. This doesn't go that high, but these all have the same basic manufacturing processes, this one. And so I'm going to use this one as the example, and this is a 0.1 microfarad 400 volt DC rated paper and foil capacitor. Okay, and we'll look at which one this one was in a few minutes. But we're going to use this as the test subject, if you will. Okay, so when you're doing this in capacitor test mode, there's a tremendous amount of voltage that can go onto here. It's controlled by this voltage knob, and as you can see, it goes up to 500 volts DC. So you can get hurt on these things here. And the reason that you do this kind of test, though, is that you can test these with ESR meters and voltmeters and ones that have capacitor testers, and there's all kinds of different failure modes that they have. And what I'm specifically going to show here is the idea of this thing becoming electrically leaky. And, you know, multimeters are putting out less than a volt, you know, into these things. We're going to see how this thing does as we try to get to 400 volts, which is how this thing is, you know, rated. And we'll see how it performs. Okay, so now what we're going to do is I'm going to hook up the capacitor. Polarity doesn't matter because this is not electrolytic. If it was electrolytic, you have to take that into account. You've got to be observant of that. I'm just going to set that right there. Okay, I'll put it here. Okay. All right, so we got the voltage all the way down to 0. We're going to switch this to paper mica test. Okay, I'm going to paper mica test. And what we're going to do is bring up the voltage. Now you see that the eye is open. And when you see the eye start to close, that means that there's current, DC current going through here. So as I turn the voltage up, you may see this thing close as it takes the current to charge the capacitor, and then it starts to open back up as it begins to charge and the current slows down. If you look at other people's examples of this, they'll show modern capacitors and they'll go like that. You know, they just go snapping right back open. Okay, they just don't have any leakage at all. So we'll see how this one does. Okay, we're in paper mica. Let's come up with the voltage and see what we get. So you saw it shut and start to reopen. Okay. So that should be reopening. And it's just almost not doing it at all anymore. So, like I say, if you compare this to a modern capacitor, that thing is wide open by now. Okay, I've got that thing shut, and it's not hardly moving. I'm looking at it on the television. I can see something there, but it's not. You don't really see that in person very easily. Okay, so this thing is taking DC current right now, and it's just flowing through it. Okay, this knob is currently set at, looks like about 175 volts, probably. So this thing is already acting like a resistor, okay, and it has it's hardly had any use on it at all. I'm going to go ahead and turn this down and turn it off. But my point is, it's about 170 volts here. It's nowhere near a 400 volt rating, okay, and it's already failed, as you can see. So, question is, so this thing is already starting to act like a resistor. Where was this, and what difference does it make? Well, that particular resistor is this one right here. That's that 0.1 that goes across the ends of the secondary of the transformer. Okay, so this is already starting to act like a resistor, and the resistance is going to continue to drop. I showed a video not long ago that was kind of meant to be kind of humorous, where I had taken a capacitor that was one of those so-called death capacitors and hooked it up with a AA battery and had it light a light bulb. Okay, gives you an idea what a dead short it had become with 1.5 volts going through it. Well, that's what these things can do. Okay, so you imagine as this resistance starts to drop towards nothing, then that's going to cause a short across that coil, and that coil is going to overheat, and that coil could fail, and then we've just lost our transformer. Okay, and we've got other capacitors in here too, but that's a good example of why we do this. So we take these things out and we place them with modern ones, save our transformers, and that's why we did it, and we're glad we did. So there we are, guys. It's all put back together again, ready to go back to the owner. He's got a 53 Chevy. He's going to put this in, and I hope he really enjoys this. It's been a really interesting project, quite a bit different than a lot of the ones I've been working on, and it's been very, very interesting. I really appreciate the opportunity to have worked on this for him. He's a friend of a good friend of mine, and so I was able to do this, and I was happy to do it for him. So it's going to go back to him, and I hope he enjoys it. And I really appreciate y'all watching. I hope y'all enjoyed it too. And we'll see what's coming up after this. So thanks for watching. Appreciate it. Talk to you later. Bye, guys.